This video explains how to build a robot tool to transport products. Attach the robot tool to the robot arm and configure the motion setting to transport products by the following steps. Open the robot tool created in the Part 1 or the downloaded file model a gripper Part 2_before.vcmx. Expand robots under Models by Type in eCatalog. Click Visual Components. Add generic articulated robot. Select the robot tool. With PNP in the manipulation group selected, drag and drop the robot tool to the robot arm and connect them. Add a product to be transported by the robot. Click Products in Containers under Models by Type in eCatalog. Add Lathe Comp 3. Select Move in the manipulation group and move the product to the position under the robot tool. Select the Program tab. Select Jog in the manipulation group. Select the robot. Rotate the claw of the robot tool so that the y-axis rotation value becomes about 0 and the claw is oriented in the -y-axis direction. Since the upper part of the robot arm is slightly facing upward, move it in the -z-axis direction so that it is parallel to the floor. In the Jog window, select TCP from the pull-down selection of tool. The pink circle is moved to the tip of the robot tool. TCP is a frame that determines the position where the robot tool grasps the product. Since TCP is set to the tip of the claw of the robot tool, the product can be grasped with the tip of the claw. Since the value in tool is restored to null if the reset button is pressed before settings such as a motion setting are set, save the setting with TCP selected. Click the gear icon on the simulation control bar. Click Save State to save the setting. Set the robot motion in order. In the Program Editor window, add point-to-point motion statement to main of subprograms. Point-to-point motion statement records the robot position and moves it sequentially along the axis. Click Snap in the Tools group and align the robot tool with the center position on the top surface of the product. Move the robot tool in the +z-axis direction and add linear motion statement. Linear motion statement records the robot position and moves it sequentially at the shortest distance. Set the open or close motion of the claw to grasp the product as follows. A signal to open or close the claw needs to be sent. Before setting the signal, check what signals are used for the robot tool. Reset the simulation and restore the initial position of the robot. Click Signals in the Connect group. Click the robot. The signals being used are displayed. Since PNP is used, the signals between the robot and robot tool are connected. The signal operation can be checked during simulation execution. When the simulation is executed, the robot tool moves along the specified position. The simulation is paused because the program set in main of subprogram has been executed. To check the signals for opening or closing the claw, perform the simulation. Click in _J1_action to open or close the claw. When the action signal is false, the claw opens. When the action signal is true, the claw closes. The action signal uses the robot output signal 100. When the claw opens, 101 is sent to the robot input signal. When the claw closes, 102 is sent to the robot input signal. Reset the simulation. Set the open or close motion of the claw using signal. To keep the claw closed until the robot tool moves above the product, set the robot output signal 100 to true by the following steps. Add set binary output statement under PTP P1 TCP. Set output port to 100 in the Statement Properties window. Select the checkbox of output value to set the signal to true. To open the claw after the robot tool reaches above the product, set the robot output signal 100 to false. Add set binary output statement under LIN P2 TCP. Set output port to 100 in the Statement Properties window. Leave the checkbox of output value unselected to set the signal to false. Configure the settings so that the robot waits for the claw to fully open to prevent the robot tool from colliding with the product before moving on to the next motion. Since the input signal 101 is sent when the claw opens, configure the program so that the robot waits to execute the next motion until the input signal 101 is sent. Add wait for binary input statement. Set input port to 101 in the Statement Properties window. Select the checkbox of input value to set the signal to true. Reset the simulation and restore the initial position of the robot. Perform the simulation. The robot moves above the product and waits for the claw to open. Next, how to move the robot tool to the product and grasp the product with the claw is explained. With jog in the manipulation group selected, move the robot tool in the -z-axis direction to the position where the claw can grasp the product. Set the 3D world view to the front and check the position of the claw. To make the component easier to be seen from the front, turn on the orthographic projection mode. Close the claw and grasp the product. Select the robot tool and check the value in joints in the jog window. The value of about 25 is displayed. Since the robot tool closes at a position of about 25 mm, change the claw close position to 25 mm. Select the Component Properties window and set J1_closed value to 25. Turn off the orthographic projection mode and check that the claw and product are placed correctly while rotating the viewpoint of the 3D world. When they are placed correctly, click the robot and add linear motion statement to move the robot tool to the current position. To grasp the product after moving in the -z-axis direction toward the product with the claw open, set the robot output signal 100 to true. Add set binary output statement. Set output port to 100 in the Statement Properties window. Select the checkbox of output value to set the signal to true. The robot waits to execute the next motion until the claw fully closes. Since the input signal 102 is sent when the claw closes, configure the program so that the robot waits to execute the next motion until the input signal 102 is sent. Add wait for binary input statement. Set input port to 102 in the Statement Properties window. Select the checkbox of input value to set the signal to true. Set the motion to grasp the product after the claw closes. To grasp the product using the robot tool, send an output signal to do so. Add set binary output statement. Set output port to 1 in the Statement Properties window. Select the checkbox of output value to set the signal to true. Set the motion to lift the product after grasping it. To lift the product to the same position as LIN P2 TCP, copy LIN P2 TCP. Paste it under Set Out. Reset the simulation. Perform the simulation. You can see that the robot tool is not grasping the product. Since the grasp motion is not set to the output signal 1, the robot tool does not grasp the product. Set the motion to the output signal 1. Click the robot. Expand Actions configuration in the Component Properties window. Signal Actions is displayed. Select one for output. Since on true is set to grasp and on false is set to release by default, use the default setting. For using tool of grasp, set TCP to grasp the product by using the tip of the claw. Reset the simulation. Perform the simulation. You can see that the robot tool is grasping the product. To return the robot to the initial position after the robot tool grasps the product, configure the following setting. Copy PTPP1 TCP since it is the initial position. Paste it under LIN P4 TCP. Reset the simulation. Perform the simulation. The robot tool grasps the product and returns to the initial position. This is the end of the explanation of how to build the robot tool to transport products. Thank you for watching.